Alright, for week 3, I guess, in this class, I want to talk about matrix operations. In particular, addition, subtraction, and multiplication of matrices. And first, I want to talk about addition and subtraction. For these two matrix operations, you're going to have two matrices, one on either side of the plus or minus, and they have to be exactly the same. They have to have the same number of rows and the same number of columns, because we add and subtract matrices spot to spot. So here's a matrix, 2, 3, 4, negative 3, 4, 5, and if I want to add it to something, I have to add it to a matrix that's exactly the same. So it has to have 2 columns and 3 rows. By the way, we call this a 3 by 2 matrix, and this is also called a 3 by 2 matrix because of the rows and because of the columns. So when I'm picking something to add to this first matrix, maybe we call this first matrix capital A and this one capital B, I have to pick something that fits into this pattern. Once I do that, my answer is going to be exactly the same as these two are. So I'm going to take and add it this way. 2 plus a negative 2 is going to leave me with 0. Alright, again, adding these together term by term, I'm going to add 3 to 5 and get myself 8. 4 plus 3 gives me 7. Negative 3 plus 6 gives me 3. 4 plus 3 gives me 7. And then 5 plus 7 gives me 12. This is my final answer for addition. Subtraction would have worked exactly the same way, except I would have subtracted it term by term. But next up is multiplication. And multiplication is next up is multiplication. And multiplication is a little more tricky for matrices. Multiplication follows a slightly different process. In multiplication, I'm again going to have two matrices, and my goal is to multiply them, but my final size of my matrix is going to be a little bit determined. I don't have to have the same sizes. So if this guy's an m by m matrix, I can multiply him as long as I'm multiplying him so that this guy's columns match up with this guy's rows. That's the key. Those are the only two numbers that have to match. And my final answer is going to be a matrix of this size, the size of the outer two parts. So following that as a guide, let's do some matrix multiplication. I'm going to pick for myself a 2 by 3 matrix. Because I picked to have 3 columns on my first matrix, this means that I have to have 3 rows on my second matrix. And once I've picked these things, this tells me already what my answer matrix is going to be. It's going to be a 2 by 1. It's going to have 2 rows and 1 column. So I fill in my 2 by 3 matrix, and I pick my 3 by 1 matrix. And now let's talk about matrix multiplication. Here's how it's going to work. My final answer is only going to have 2 rows and it only has 1 column. So my final answer only has 2 terms. And here's how I get those 2 terms. The leftmost matrix, I'm going to go left to right. And the rightmost matrix, I'm going to go top to bottom. And here's what happens. Let me give myself some more space. This one over here, just so I can write out what's happening. I take 1 times 4, this gives me 4, and then I add a plus sign. Then I take 2 times negative 2, this gives me negative 4, so I'm doing 4 plus a negative 4, I add a plus sign. And lastly, 3 times 5 gives me 15. When I'm ready to do my second row here, This is the second row. It's still the first column, so I use the second row, but still the first column to get my answer. And I get 4 times 4, and this gives me 16. And I get 5 times -2, and this gives me -10. And I get 6 times 5. This gives me +30. I can simplify my answer matrix. 4 plus a -4, those cancel out. This leaves me with 15. 16 minus 10 is +6, plus 30 leaves me with 36. This becomes my final matrix multiplication answer. So I've given an example of addition. Subtraction would have worked just the same way, except I would have subtracted the terms. When you're doing addition and subtraction, you have to have matrices that are exactly the same size. If they're different, you can't add or subtract them. For multiplication, you don't have to have the same size. You just have to make sure that the columns of the first matrix match up to the rows of the second matrix. And then your answer matrix will be the size of the first guy's rows times the last guy's columns. Notice that if I try to multiply these matrices the other direction, if I try to do this guy times the first one, that wouldn't work because this is a 3 by 1 matrix and this is a 2 by 3, and these two don't match. This does not have a multiplication that works. Matrix multiplication, it matters what order you do it in. This is different than saying, well look, 2 times 3 happens to equal 3 times 2. That's true because both of these are 6 under normal algebra. The matrices are different. Matrix, you can't flip the matrix multiplication around. The order matters, and it gives you one final answer provided these two numbers match.